Welcome to domain of a function day 2. So try to complete your do now on your own. But I'm going to go through the mini lesson, and that should help you with the do now if you are stuck on the do now. So I'm going to zoom in a little bit here on this mini lesson. This is just review from domain of a function day 1. So it should look pretty similar if you're all caught up to this point. So if we're finding the domain of a given graph or interval notation, the first thing I want to do when I'm finding domain, remember I'm thinking domain, I'm thinking my x-axis, my x values here. I'm going to find my most left and my most right x value. And I'm going to mark it by going like this. So I know that right here, this is my most left value. And that looks like we have -1, -2, -3 is my most left. And on my other side of this very lovely pentagon, I have my point right here, which looks like a +3. So we have 1, 2, 3, and then the 4. So we have +3, -3, and +3 are our two most endpoints here. So those are going to be our 2 points. And because we don't have a very obvious open circle, we can assume that these are closed circles. So we know that closed circles end up getting our including, right? Less than or equal to, and including that point line that goes underneath. And it gets our kind of tough, harsher brackets there. Whereas our open circles is just less than, it's not equal to, and we would have our parentheses. So when we're writing interval notation, we're going to start by listing our lowest value and our highest value. We always have x in the middle, and it'll always be less than. Now we have to check if it's less than or equal to. We have to remember to add our lines underneath for less than or equal to. For our set notation, which is oftentimes a little bit easier, we just write in our lowest point, our most left point, and then our most right point with a comma in between. And then thinking about our brackets, we know that if we're including both -3 and +3, we're going to have our brackets here on both sides because we're including both -3 and +3. And can we define this function as a graph? I'm going to do my vertical line test, and I can see right away that this does not pass my vertical line test, right? Because for each of my vertical lines, for this input of -2, for example, I have an output here at 1, and I have an output here at -4. So I have 2 outputs for 1 input, and I cannot have that. No, you'll see that multiple times throughout our vertical line test, right? So no, this graph is not a function because it does not pass the vertical line. It does not pass the vertical line test, or you can say, right, because every input does not have exactly one output, or every input has multiple outputs. So any of those definitely work for that one. Good luck. Let us know, as always, if you need any help.